Hi, welcome to FunNetPy videos. This is DC here. This video is about PN5180 board registers and register the read and write instructions. So I would like to cover the following things in this video. So we'll have a quick run through about various registers in this board. You have to refer the data sheet throughout this video series. There are around 40 registers in this processor. This is a mix of both read-only and read and write registers. Each register has got 32 bits. So if you want to master this chip, you have to understand the working of every bit. And as I mentioned in my earlier videos, this chip, to understand, you need a mix of a skill set. You need people who can do the programming, working with bits and bytes, and you need people who understand the signals and voltages and antenna stuff. And even the bit level, there are read-only and read and write bits. So there are, looks like there are so many bits to understand. So in fact, you'll end up having around 32 times 40 bits to understand. But I would say 20% of the bits are not used. They are referred to as RFU. This is for the future use. So in that way, we are lucky that you're going to read in a less number of bits. We are going to see only the read register command and the write register command. And in my future videos, I'll be showing you the various other commands. So read register command is pretty straightforward. You specify the name of the register and you'll get the 32-bit value. In the write register, there are three variants. You can write the entire 32 bits, or you can just set or unset few bits. So this is the bitwise AND operation, or you can also do the bitwise OR operation. So I'm going to show you some of the usage of these commands. Now this is the software I've been using in all my previous videos. Now this software is in the version 1.1. So I'd like to show you some of the changes has gone into the software since the last release or last video. So we have added a menu called options. If you click that, you can see the release notes. So this is a fairly new software. So there are only 2 releases. So the latest release, what it says is you can download the Arduino source code within this software. And also there is a new command added, that's the writing the multiple registers. And if you go to the options again and choose this Arduino wiring, so this is the wiring I mentioned in my previous videos. So there's a quick reference to that wiring as well. So anytime you can get access to this wiring. After that, if you choose this Arduino source, you can see it's asking you to choose a local folder and hit the extract. So the entire Arduino source code along with the hex file will be extracted to a local folder. So every time you get a new release, probably now I would recommend you to look at these release notes and find out whether you need to install the latest hex file to Arduino board. Now you can see I've got my Arduino connected to PN5180 board here. So we have seen the working of this software in my previous videos. If you hit this connect, hit this console. I'm just going to quickly walk through some of the things here. So we have seen in my last videos, there's no changes that happen in this tab, in the registers tab, except probably you can see some a new button here called write register multiple. And in the EEPROM tab, there are no changes. So this tab shows you all the EEPROMs data along with for you to read and write the EEPROM. And the configuration here, there is no changes. So I'm going to come back to this soon. The command section, there are quite a bit of changes gone in here. The first thing is you can see all the instructions here. So if you choose an instruction, so the instruction is going to tell you what kind of data you're going to key in. This is just kind of a help. So it says the write register command. It says, put the register number and put the 4 bytes of data. So the number of the registers, you can either go to the registers tab and find out, or you can drop down this this list and you can find out what is the number of the register. So one more interesting thing has gone in here. This called this is just a good application of using various commands to activate the tag A. This I mentioned briefly in my last video, so I'm just going to, this is very interesting to know. I'm going to here I've got a MiFi classic EV1 tag. I'm going to hit the activate. Now I know it's not going to work because first thing what you have to do is you have to set this RF, you have to set the radio frequency on. So I'm going to hit that. You can see the response here. Then go to type A and hit activate. This returns you the ATA, SAK and the UID of the tag. Likewise, you can, I've got a few other tags here. Click activate. You can see you got something, a different ID there as well. And I've got probably NTAG 213. Activate. Now in my later videos, I'm going to show you how to get this thing done. There's lots of commands that are gone inside to get this output. Okay, so that was a brief overview of this screen. Now this video is all about the registers. So as I mentioned before, you have to have a copy of this. Now, there are so many registers and so many bits. If you go to page number 87 in this datasheet, this lists out all the registers, and for each register you'll also find information about every bit and what it does. And you just have to go through, because as I mentioned before, this is a mix of the skill sets. So my background is from the software development design side, but I would say 60% of this data sheet is all about the antenna design and also signal. So I'll be just focusing on what is required from the software development point of view. So you can see every register has got a register ID. They're called address here. And if you go to page number 22, here you can see probably all the instructions. Number 22, probably a little bit, yeah. You can see here, these are all the various instructions. Again, every instructions, they look very, very simple instructions because the amount of data you send with each instructions are pretty easy to understand, simple. So the first thing you're going to do is, you need to, assume you want to read the registers. The registers are the internal memory of this processor, the PN5180. So you would like to read, and to do that using the software, you just select the register and say click this read button. See, the main objective of this video is to show you these commands, how to send these various commands and what kind of data you get from there. Because as I mentioned before, to understand this, say for example, understand register system config, and if you, as soon as you click here on the right side, you can see all the bits, and you have to go through the datasheet to understand what each of these bits does. So I can just briefly explain, tell you some of these things, but not everything. If you go and hit this search, show RFU bits. So as I mentioned before, some registers, they do have unused bits, so they're called RFU bits. And if you see this yellow color, it means they are the read-only bits. You cannot modify them. If you try to set, you can't. So likewise, there are some registers whose all the 32 bits are read-only. So in that case, in that sense, these registers are also made as a read-only registers with yellow background. So you can untick and hide all the RFU fields. So this is how you read a register. You just first choose and just hit the read. So likewise, every time you read, you get the 32-bit value. So the command for read is 04 is a read register command followed by register number. So it's very simple. Now there is a command to read multiple registers, so which it's very obvious that when you work with the embedded systems or the microcontroller level, we always try to avoid or reduce the amount of data that is passed between the host or the PC or the board. So using the read multiple register command, you can read the content of more than one register. Say for example, I would like to read the content of the first 4 registers. You just have to select here and say read multiple register. Now the command is again very straightforward. It's a 05. So this is the instruction for the read multiple. You just pass all the register numbers, okay, in this sequence. So it doesn't have to be in any order here. You can have a different order. So 00, 01, 02, 03. So this is going to return you 4 bytes for each. So there will be 16 bytes in the response. What the software does is extract out all the 4 bytes each, and populate the grid. So that's as simple as that. Now sometimes you can read the registers in a different way. For example, there is a command called read configuration register. Now I mentioned this in brief in my early videos. Before you can do any RFID like a activate a tag operations, you have to first initialize the board for a specific protocol and the speed and the frequency. So here by default, when I say by default, when you power this board, it is set to this. The transmitter is set to type A and the receiver is also set to type A. So we don't have to assume that. Probably most of the time I've seen with this setting I'm able to activate the tag. So if you want to change, I'm going to spend a separate video on this, but because this is something to do with the reading the register also, I'm going to load this configuration, clear the screen. Now I would like to read, see, every configuration affects or the data for every configuration is stored in a register. Now you can find out all the registers that are affected or used by this configuration. So in order to know how this configuration are stored in various registers, so there are 2 commands specifically for this. The first one is, the main thing is to get the list of the configuration register, but in order to do that you must know the size of the number of registers. So it is done in a 2 step. First I'm going to hit this get configuration file. Now this is a command that's 13 and 00. So 00 is the name of the protocol. Now this command basically is telling that you would like to know the configuration registers for the protocol 00, and the CPU says there are 8 registers that are used to store this protocol. And now if you hit get configuration register, so this is going to read now all the 8 register content. So you'll have 8 times 4, 32 bytes altogether. Again, the command here is, you have to say the 14. This is the command, and followed by, it doesn't make out what's 28 here. Oh sorry, the 28 here, it means probably it's the number of sorry, I was wrong, completely confused here. So this command, you have to specify the 14, that's the read config register. Then you have to specify what is the protocol. Then you have to specify how many bytes you want to read. Now I always go with the 8 times 4, 8 registers. Now when you get the response for this command, you will come across some register values here which are not defined in this list of registers. So looks like these are all a kind of a reserved or internal registers which are not available for the programming purpose. So if you see the highest register number is 29 in hex, whereas if you see the output of this get configuration register, it goes up to 2F and 42. There's nothing to surprise here, because the documentation mentions, if you look at the datasheet, it says that these two register ranges are called RFUs. So it's there, just at accept, it's there, but if you know anything more about this hardware part, you'll understand what this registers and the value does. So likewise, you can also read the configuration registers that are used for the receiver side of the protocol. First you hit the get, you get you get a different number here. So there are 11 registers altogether, and if you say configuration here, you get the content of 11 registers. In fact, I just have to mention here the output here. So it is just not, let me check here. Okay, it's just not, probably not the raw data. So here, see the output, what you see here is just because you're getting the content of 11 registers. So obviously there must be somewhere in this data that tells you what register it is. So the very first byte is the register number, followed by 4 bytes of its data, then the register number, followed by 4 bytes of the data. You can refer, you can match what you receive here with the grid of data. So it's 1F, so that corresponds to this register called AGC value register, and these are the values. These are the 4 bytes of values. So this is the lower byte. You can see a lower byte, 0, 1 upper byte. Okay. So this is how you read the content of this configuration registers. You can change this protocol. Assume that you want to know what are registers that are used for Felica protocol. So choose that. I'm going to clear this thing. Get the configuration. It says there are 8 registers used to store this configuration. You can, if you hit this get configuration button, you can see there are 6 known registers, but the one is RFU with this value. So the next thing is about the writing. So I mentioned before, register write operation is done in 3 different ways. One is a normal write, one is a bitwise OR. So literally now you the 32-bit value enter here is the 32-bit mask, and the AND mask is a bitwise AND operation. So assume that I would like to change. Again, you have to know which registers you're changing, because there are so many registers in which I myself don't know what they do. So I'm going to go with the safest thing. Probably I will go with the, say, IRQ clear. So I'm going to change this, but this is not the best example. Go with the IRQ enable. So if I hit here, this is the current value. I'm going to change this value to, say, 5560. And if you hit this write, now this is the structure of the write command. See, for every command, the Arduino side of the program returns a 0, 1. It's just to make this software wait for some response. Otherwise, these software, they run at a lightning speed compared to the speed of your Arduino. So probably if you start sending a series of commands one after another, you might end up sending more commands than the Arduino can process. Actually, when you do the write operation, you should have the write ready button ticked, not this one. So I'm going to try again on a IRQ enable register. So I would like to set this as say 5560. Now because we typed only 4 bytes, it is taken as a least significant value. So automatically the value gets padded with zeros. Now I'm going to use a write operation here. So to make sure the write is successful, I'm just going to clear zeros here and try to read. Okay, you can see that so we are able to read what was written. Next thing is the write with the logical OR operations. So these type of write are used to, if you want to specify, you want to set any single bits of the register. Say for example, sometimes register values are well understood by working with the bit level. So assume that I would like to set just this one, and probably the best thing to do is just go here. I want to set this bit, this bit. You can use this select unselect to, to have everything ticked or unticked. So I would like to set only these two values, or for example only this value, and I still want to keep all the existing values. So I'm going to use the write with the logical OR operation, and this is going to set only a single bit of the register. So now if I hit a write, now the instruction command code is 01. Initially it was 00 for write the full write operations. If you try to read it, you can see that initially it was 5560. Now with this bit OR operation, only the last bit is set to 1. So that's one of the use of this OR operations. So likewise you can use the write AND operation. So it all depends on what you want to do. Assume that I would like to clear, I want to keep everything as it is, but I would like to clear. Well, the best thing to do is work here on this side. So I would like to clear these two bits. Update. Now this is the mask. You can see here some of the values, even though it is all set, the values are still 0, because what the software is doing is it is not changing the values of the RFU bits. So almost half the register size here is RFU. Now this one I'm going to use as a write mask, and if you hit this write operation here, so this is going to clear just 2 bits, and if you try to read, you get a different, the last 2 bits are reset. So there is a bulk write operation as well, very similar to bulk read. So using this operation you can write multiple registers at once. Again, this has got a different flavors. So what the software is doing is just using either you can assume that you want to write to 5 register. If you see the documentation, you can specify whether you want to write a normal write or a write with OR or write with AND logic for every registers. It's possible with the write command, but this release of software doesn't have that. You can either use a write operations for all the registers, or you can use a write OR. So I'm going to show you now a couple of these examples. Now assume that I would like to write, say, all FFs here, FF for that, maybe all FF here. So I'm going to clear, I'm going to write to this, and that. Okay, so I've got 3 registers I've selected, and I'm going to use a write operation, a proper 32-bit write. If you hit this, look at the command structure. So it is a 03, that's the write multiple, followed by the information about 3 registers. Now for each register you have to specify the register number, which is 01, and what type of write you want to do, whether you want to apply a normal write or in that case this will be 01, or AND, this is 02, and the value you want to write. So these 6 bytes corresponds to one single register write. The next 6 bytes again says you want to modify or write it to register number 3, and the normal write operation 0 and the value. So likewise for third register. So if you start reading this, now somehow you got a different value for RFU. Now, so we are more interested in the instruction and commands in this video tutorial, and it doesn't matter why you got this value. So this is how we use the write multiple operations. I could have used a AND here, OR here. So if you hit write, now you're going to get the write. So the documentation says this has a register number, this has action, and this has the data. Now the action is set to 01, that corresponds to the write with the OR operation. And if you look at the documentation, probably you'll understand this better. So I'm just going to see the documentation. Now this is the instructions we are working now. Write register multiple. the command code is 3, and you're going to send 6 bytes for each register. The first byte register number, the action, and the 4 bytes of register content. The action is 0, 1, 0, 2, and 0, 3. I'm sure the software says 0, 1, 0. I think the software is wrong here. It should be 0, 1 for write operation, 0, 2 for a OR, and 0, 3 for a mask. If you try to do that for AND operation, let me try write multiple. It's going as try this normal write. So for normal write, it's going as a 0, 0, and for the OR, it's going as a 0, 1, and for the AND is going as 0, 2. So this is a bug in the software. It should be 0, 1, 0, 2, and 0, 3. So probably not this will be fixed pretty soon. Probably you don't see this bug by the time you try this software. So I'd like to finish this video by showing you the structure of this Arduino side of the program. Now I'll be going through some of the code in the core, the library, because we have added few functions to the core library, and this is a very simple C program. There is just a series of a switch or if then else statement. So based on the very first byte that comes from the PC, so it is branched out as depending on the command. Say if it's a write register, so I'm calling this write register command of the library. So likewise, there are a few commands added. So for example, here it's called the Cephanet Pi activate type A. Now this command calls a method called activate type, and this is the command that does all the all this REQA and in a sense maybe 10 or 12 different commands, and that returns the UID. So it's really good if you go through this program, understand how these type of programs are written. So I think that's all. We are almost at the end of the video. So thanks for watching. I'll be covering more stuff in my future videos.